So hello everyone. Today I gonna show you how can you create a heap in a C program without using malloc functions. Okay, it is going to run in Windows. So if you have Windows, you can run it. Otherwise, you cannot run it. So here you can see a sample program. So now let's explain what this program does. So here is a heap create function. You can see here heap create function basically create a heap which our programs can contain multiple heaps. So this is a heap which I have created. Programs have a default heap, and we can create more heaps as we need. So here I am created I have created a heap. I have created a heap which contains uh, one KB uh, 1024 1024 size, initial length, and 2048 of maximum length. So I can create this value of I can create 1 KB initial and 2 KB maximum. Okay, heap create function gives a handle to heap. Handle is just basically a pointer to the heap structure, or you can say internal things which I have not discovered yet. So it just point on the our heap. You can say that. Now, second line we have a heap alloc function. Heap alloc function just basically does at as malloc does. Malloc, what happens in malloc? Malloc just create a memory and give it to you using void pointers. So here it is also done same. Here it is create using this heap handle. Here it is alloc memory in the heap handle. As you can see, I have passed heap in the first parameter. First parameter takes which handle, which heap in you want to store this value. So I just passed our heap handle. Next, I have said heap zero memory. It basically says that when you create the pointer, it will not contain any garbage value. It will just contain a zero value of this type. Okay, here also if I made it float or other types, it will be automatically zeros on that type. Okay, now size, here it is needed size. So it's basically asking about very type size. Okay, so here I give my integer type size. Now after this function we have created a variable called a. So a just basically contains the memory which I allocated here. Now here I have referenced and assigned my value to assigned value to my heap. Here you can see I have assigned 10 to my heap, and also I have heap free function. So heap free just basically do when I have created, when we create any any variable, any dynamic allocated memory in heap. So it's just free this memory or those memory using the heap handle. So it's take heap handle and it's check this variable of, here you can see here int pointer a. So I pass the variable a. It will check if a contains in the heap handle. If heap handle contains a, so it just basically free that memory. And now we have a important function heap destroy. So heap destroy just basically does when I create some heap and allocate memory on it, so it just free the heap, whole heap will be freed by heap destroy. So it is a masterpiece function. If you forget to allocate deallocated any memory using heap free, so you can just call heap destroy, and heap destroy will clean all this memory for you. So it just syntax like this. Its contents on the windows.h header file you can see here. Now you can learn it from also Microsoft documentation. So just give me time. Here is a documentation about this. So it contains on here you can see it contains on the kernel 32 the lib file, and header file is head.api.h. Just you can see, and here I have no need to include my head api.h. I have only include windows.h, and windows.h also includes this, so automatically it is included, no worry. Now this is a simple experiment where we're going to see we have seen that we can create any heap allocated memory without using this heaps, without using malloc functions or other functions we have used before. So it is quite amazing that we can create multiple heaps. So here is a function get process heap, you can see here. This function basically does it returns the handle, uh, whatever I have told you handles what is. So it returns a handle of the process heap. We can create multiple heaps on our process, so it just basically returns you heap default heap obviously. So it returns you the default heap of the process. So here you can see what returns. If succeeds then returns, or not, so if not succeeds then it will return null. You can check it and confirm it returns or not. So this is the function, and we have also a function called get process heaps. So this function also does same, but uh, it returns all the heaps which we have in the process. So here you can see that we have need to number of we have to pass here number of heaps and process heaps. Okay. So just basically it says that you have to maximum number of heaps. Uh, it means that you have to give it a number how many heaps you have stored. So it's still here you can pass any number that it will check that uh, these how many heaps are there, and it will return you the number of heaps. uh, it will return the number of heaps whatever you have passed in the number of heaps variable. Okay. So it will not return all the heaps, it will return only the number of heaps whatever you passed these that many variables, that many heaps. Okay. And here you can see one these process heaps or p handles. So it is just content, it can contain all the heaps which we have in the process. So it was basically does it contains all the heaps. It is a structure, or you can say it is a structure. So this structure will contain all the heaps. Now you have to create a p handle and pass it to get process heaps. You don't need to initialize it, it will automatically initialize it. Here you can see it is written here out, so it just basically does that. Now it also include in the kernel32.lib, so you just no need to worry, because any program we have made in the C language, most of them are already linked with the kernel32 lib, so no need to worry. Now we have a multiple functions here, you can see. So we have a realloc. So this is the important function. If you want to realloc any memory, so you can do it. Now there is many more multiple functions you can see here. So it is heap size, retrieves the size of a memory block. So it gives you the size of the memory block. And now two more important. Now heap lock function. So it attempts to acquire the critical section object or log the associated with the specified heap. So it just lock your heap in that module. Module means, you know, a process can contain multiple threads or modules, just like your program kernel 32 lib, just like that. So if kernel 32 create its own heap, so it he kernel 32 creates its own heap that does not want to share with your program, then he will just lock uh, the heap, and the heap you cannot you cannot able to get the heap handle using get process heaps or whatever functions I have shown to you. So this basically then does this. So heap log is a great function if you want to log your heap in your module only. So this is great function, because if you want to create if you want that your thread heap does not access by other threads, so you can do this. Now we have unlock functions. So it basically does that what heap lock does. It's just opposite. It unlocks the heap handle and available to other process or modules to use it. Okay. Now here are many more functions you can see. If compact, if whatever is there. So just it's just basically that. So now we have a multiple more options to create heap, like virtual alloc. So let me search it. So here is a virtual alloc, you can see. So it just basically does like heapalloc, but different way. So here you can see whatever is this function. So here is the description. So it is told that reserves, commits, and changes the states of regions pages in the virtual address space calling process. Memory allocated by this function will automatically initialize to 0. So it basically says that it will done by process heap or memory allocated by this function will automatically zeroed. It just basically says its properties. So now we have one more alloc. So we have GlobalAlloc. So this is the function called GlobalAlloc function. So it can also allocate memory on the heap. This function, what does this function? Allocates the specified number of bytes from the heap. So it just basically does allocating memory from the default heap. I think you can read this documentation and you can discover. Now we have local alloc also. So in the conclusion, you can see that many allocate functions are there in the Windows. So it is just basically on Windows, because here you can see whatever it needed kernel 32 lib, which you can only access in Windows, not a Linux. So it is just it is basically a Windows kernel level syscalls, which is done by these headers or library files. You can see that. So this is all. You can search it and read the documentation and you can use it. uh, so many you have one questions like that, and why we should not use malloc, or why should we use this allocation like. So if you use malloc, so malloc is not directly called in the using syscalls. It is more process to do it. Now I have discussed malloc in the another video, you can see that. And malloc does not call directly syscall. So that reason malloc has a overhead, runtime overhead, you can say. So these functions are more secure and more fast to do. And one benefit is that you can create multiple heaps for one process. It is too easy to do this using these APIs. If you want to do using malloc or other functions in standard library, you cannot do this easily. So that is the basic difference. Overall, it can say, you can say that it directly or indirectly calls these functions, but the malloc has its own overhead, runtime overhead. So that's all. Now this is all in the students experiment. Thank you for watching.